Is an oxygen sensor? Well, this right here, this is one of the oldest types of basic oxygen sensors that we have, and it's what's known as a single wire oxygen sensor. Now the way this thing works is this end, the tip, screws into an exhaust manifold through a surface called a bung, and it's going to be mounted down in the exhaust stream of the vehicle. Now as the exhaust gas passes over that sensor, it's going to do two things. Obviously, the air that we're breathing has a certain percentage of oxygen. It's actually, our atmosphere is made up of 21% oxygen. The exhaust gas in the car has a lower content of oxygen. It might only have 1 to 2% of oxygen. So one side of the sensor, the outside here, this part, is exposed to the atmospheric air that we all breathe. The other part here is mounted down inside the exhaust manifold. It's basically living in a poisonous atmosphere. The way the oxygen sensor works is it measures the difference of the oxygen content between the oxygen outside and the oxygen in the exhaust manifold, and it actually generates a small amount of voltage like a battery. The battery voltage is very weak. It generates about 1 volt, and it only generates this 1 volt under extreme conditions. It actually has to see a very low oxygen content on this side and a very high oxygen content on this side, the part exposed to the outside world that we all breathe. The other thing is the sensor itself actually has to reach about 600 degrees before this battery actually starts to work. So oxygen sensors, they have a rough life. They live in a poisonous atmosphere and they get extremely hot. And like I said, they have to get to about 600 degrees before they work. So early oxygen sensors like this guy would have one wire going back, and this wire would ultimately go back to the car's computer, and it would help the computer calculate the air-fuel ratio. If the car was dumping too much fuel into the exhaust, that's going to cause what we call a very rich exhaust, and that's going to cause a very high voltage, 1 full volt. At that point, the computer's going to see that 1 volt signal and go, I see 1 full volt. I'm running too rich. I need to lean back on that mixture, and it's going to actually cut back the fuel through the fuel injectors, which in turn is going to cause the oxygen content to raise in the exhaust stream. We call that a lean condition. The sensor at that point is going to see a very weak voltage, down to 0.1 volts, almost no voltage at all. That cycle of switching between rich and lean happens about once per second as you drive. So the car's constantly switching between this rich and lean. Now the rich and lean is a very narrow band, and it's tailored for excellent fuel economy. And it's one of the biggest reasons why cars went from carburetors to electronic fuel injection was because of this guy. This guy can't control a carburetor very well. Manufacturers had a really hard time tailoring fuel economy with a carburetor. You could set it, but as the carburetor wore out, the fuel economy tended to go in one extreme, lean, in which case the car would stop running, or rich, in which case the car would start polluting, blowing a lot of black smoke and wasting gas. Oxygen sensors really help fix this problem with the advent of fuel injection by preventing that fuel loss, giving us good fuel economy. The oxygen sensor has been around for a long time, and like I said, this older design worked great for a long time. But if you remember back to that 600 degrees, it takes time for the sensor to heat up. So manufacturers realized pretty quickly that they had to do something to help, help heat things up a little bit. So what we came up with is we came up with other oxygen sensors, like this guy right here. Now this guy has 2 wires. You notice it has a blue wire and a white wire. Colors of the wires aren't that important, but what this guy has is it has an internal heater on the inside of it. And this heater helps light up that oxygen sensor very quickly to 600 degrees within roughly about a minute. It's sort of like a miniature toaster oven. And that worked pretty well until manufacturers realized that the power that we were sending through this guy had to be returned through this rusty flange or a rusty fitting back through a rusty exhaust manifold, and the heaters were not working and the sensors were not as accurate as they could be. So what did manufacturers do? They added another wire. What we had later was a 3-wire oxygen sensor. And what this gave us was it gave us a good signal for the heater, the ground for the heater, and we still had our one wire back through to the computer. So that worked great, except that signal going back to the computer could even be better. So what did manufacturers do? Yeah, you got it. They added another wire. So what most cars have today is they have what's known as a 4-wire oxygen sensor. 2 of those wires, typically the white wires for most manufacturers, are the heater circuit, and then the black wire is the signal back to the computer, and the gray wire is a ground reference signal for that computer as well. So everything is a nice solid electrical connection now through good connectors. We don't have to rely on rusty connections through the exhaust manifold to send that signal back to the computer. So let's take a look at what's involved in actually removing an oxygen sensor. When it comes time to remove an oxygen sensor, they can be a little tricky to get at because, one, they're in the exhaust stream, and they tend to last in most vehicles anywhere between 30 and I've seen them go as far as 150,000 miles easy with some vehicles. So they're in the exhaust gets really brittle, it gets very rusty, it can be a very cramped working environment, and so sometimes getting to the sensor can be a little bit difficult. Now, manufacturers, fortunately for oxygen sensors for the most part, agreed on a standard, which is that the sensor itself takes a 22 millimeter wrench. 22 millimeters is generally the accepted size for most oxygen sensors that are the screw-in type. And if you can get onto the sensor with a wrench at 22 millimeters, that's pretty good. And you're going to need a good-sized wrench to actually work this loose. If you can't get to it with a wrench, it might be tempting to use the box end of the wrench to give you a little more range of motion rather than just the 2 flats. And we also have more grip surfaces around the base of the oxygen sensor. The problem is I can't fit this over top of the connectors. And if I cut these connectors, there's some disagreement in the industry that you can easily reassemble them and other disagreements that you can't. I'm not a huge fan of cutting and splicing oxygen sensor wires for a couple reasons. One is the wires themselves aren't actually copper. A lot of times they're stainless steel. And if you ever happen to cut open an oxygen sensor harness, you'll see that the wires are they're silver. They're not copper colored, and that is because they're stainless. The other thing is that because they are stainless, you can't easily solder stainless steel with a regular electronic soldering iron. So that connection is never really great when you go ahead and do that. The other thing is there's some disagreement from manufacturers about the actual coating of the stainless steel wire covering. This coating has to, again, to be able to withstand extreme temperature environments. And if we just put on some electrical tape or some butt connectors or something like that, or even heat shrink tubing, that's going to get really hot and it could actually fail and cause a short or your electrical connections to fall apart. Now, a couple companies do make an actual special connector that you can disassemble and reassemble for splicing harnesses together. And some manufacturers, what they'll do is they'll sell you what's known as a universal replacement oxygen sensor. And it's literally just an oxygen sensor with 4 wires. And then the idea is that you cut your old harness and use your factory connector to plug back into the computer, and then you use the aftermarket connector that you bought, and you splice the 2 together with a special electrical connector. They work fairly well. The thing you have to look out for is some manufacturers are actually now using a 5-wire oxygen sensor, in which case that doesn't work. That's called an air-fuel ratio sensor, and it's a little bit of a different type of animal. So the 22 millimeter wrench works good as long as you can get to it. Now the other thing is I like to use a good penetrating spray. If I know that I have to take an oxygen sensor out, I'm going to want to spray the base of the sensor. Don't spray the whole sensor, don't spray the wire harness, and certainly don't get a lot of oil inside the sensor. Just spray it at where it meets the exhaust manifold and let it sit. The longer you let it sit, the better it does its job. And a lot of times after you let it sit for maybe an hour or 2, you let the rust penetrant work its way in there, and it really works nicely at breaking that rusty bond. If you still can't get in there, you may have to use a special type of socket called an oxygen sensor socket. Now, these are two different styles, and this socket is designed to go on the end of a 1/2-inch wrench, and you'll see that it has this big slot cut in the middle of it. Now, the slot is designed so you can pass that over the sensor like this and get it down on top there, and you have the slot sticking out so that way the wires don't get twisted as you turn it off. Otherwise, you could just use a regular 22mm socket. The problem is the wire harness gets in the way. This works really well, but it's kind of tall. It might be a little hard, a little bit of for some confined space work. So what manufacturers came up with was this special crow's foot adapter. And this guy just slips right over the wire harness. It goes right down on top. And then I can take my regular old ratchet, put this on top here, and there we go. And just break this guy loose. Now, this is obviously been pre-loosened. When you go to remove the oxygen sensor, it's a good idea to make sure that you can get to the electrical connector and disconnect that first. Because what will happen is as you twist the sensor, if you don't unhook and unbolt the electrical connector, it's going to actually start to twist the wires, and we don't want to cause a bigger problem than we're going to need. If we have to reuse the sensor, we have to be really, really gentle with these things. So you're going to just want to unscrew the unit as a whole and kind of work the wires around. Now, when it comes time to put a new sensor back in, one of the tricks that manufacturers have learned is that by adding a little bit of anti-seize compound on the threads of the oxygen sensor are really helpful in making sure that that rust bond doesn't form again if we have to remove the sensor in the near future. Now, obviously, if we put the sensor in and we leave it for 100,000 miles, I'm not so sure how good the anti-seize compound is going to work. But one of the things that I see people make a mistake with is they think if some is good, then more is better. And the fact is when you go to put on the anti-seize compound, you really only need a very, very small amount of this. And this is obviously a whole lot. Let me just wipe some of this excess off. And I'm just going to put a dab, really, really small amount of anti-seize compound right there and only on the threads. You never want to get it actually on the sensor area itself. If you do that, you run the risk of contaminating the oxygen sensor. So when it comes time to put it back in, we simply take our sensor, thread it back in through the exhaust bung, snug it down, and then use my tool and torque it down. Okay. Make sure it's snug. When I start the vehicle, I want to make sure that there's no exhaust leaks. And at that point, if that fixes our problem, well, then we're good to go. So that's what's involved in changing an oxygen sensor, and I'm going to show you how to do it on the car behind me. But our oxygen sensor in question has a defective heater circuit according to the trouble code that we got. So how do we check that? Well, according to the manufacturer, what they're going to have us do is they're going to have us measure the resistance of the two wires and see if there's specific resistance. If there's no good resistance there, then we know that our heater inside our oxygen sensor is defective. Now, the big mistake that a lot of people make is they read the scan tool, and the scan tool says something about oxygen sensor. And they run out to the auto parts store and spend $50 or $150 or $250 on a sensor, put it in the car, do everything right, and the problem's still there. Again, you have to go through the diagnostics to make sure that you are actually replacing the part. There could be a problem somewhere else in the circuit. So we're going to make sure that we do our thorough diagnostics. The other thing is I can show you a simple way to test an oxygen sensor. And what we're going to do is we are going to take an older 2-wire sensor. Where did I put it? There it is. We're going to take this older 2-wire sensor right here. And what I'm going to do is I'm going to use a digital voltometer, which is an electrical test tool. And I'm going to set this up. And what we're going to do is I'm going to show you how the sensor works with the voltage that it's going to generate. So let me plug this guy in and hook this up. And you're going to see that as soon as I hook this sensor up, it's going to make almost no voltage whatsoever. Set the range here, and it's now set to show me millivolts. And it's effectively zero. We're looking at a scale that's really showing us, if we can imagine this is a dollar, we have a zero, a decimal point, and then we have cents, and then we have basically hundredths of cents all the way at the end. So the way that we're going to test this is we're going to heat the sensor. Now this is more of a demonstration. It's not a great way to test an oxygen sensor in a car, but I like to just demo it. This is a demo that I use for the students here. So I'm going to move the meter over a little bit so I don't get it too hot. But what I'm going to do is I'm going to take a propane torch and I'm going to heat the sensor. And you're going to see that the voltage is going to start to rise on the sensor as it heats up. Now, if you remember, the sensor has to get to 600 degrees, and that's a pretty big chunk of metal, and this is just a propane torch. And that means that it's going to take a couple seconds, if not at least a minute, for this to start to heat up. So I got my oxygen sensor cooking pretty good, and my voltage is still 0. And we should start to see some voltage come up there. A little bit of voltage coming up as the sensor starts to heat up. And the sensor should almost get to a full volt if everything's working. And right now we're at 40, 50, 60, 70, 80, 90, almost a full volt. Not quite a full volt, but pretty close. And as soon as I pull the flame away, it should immediately drop. So I should go hot, should heat right back up to where it was. If I pull it away, it should drop quickly. And this sensor is actually doing a pretty good job of switching between, this would be a rich signal right here, and that would be a very lean signal right there. So if you were monitoring this in a car, as you drove, you would see it constantly switch between that higher voltage, which is almost a volt, and then that leaner voltage, which is almost no voltage at all. So as you're driving again, that oxygen sensor is switching between rich and lean, rich and lean. It does it about once per second, and it's going to take a little while for that sensor to cool down before I can handle it.